Have you ever just looked at something you use every single day? Why is it like that? Well, today we're pulling back the curtains and the super clever logic hiding in plain sight in some of the most common objects all around us.
Seriously, just for a second, look down at your keyboard. Does that jumble of letters make any sense at all? You'd think just laying them out A, B, C, D would be way easier, right?
Or how about this one? You grab a soda and it's got those 5 little bumps, those feet on the bottom, but the water bottle right next to it, perfectly flat base. What is going on there? And that big, kind of clunky third pin on some of your electrical plugs? I mean, the other two seem to do all the work, so is that third one just for decoration? Well, the answers to all of these are way more fascinating than you might think, and they open up a whole world of incredible, hidden design. All right, let's dive in. We're going to uncover the wild story of our accidental keyboard, check out some designs that were literally forged by pressure, reveal a hidden legacy of security in our pockets and our walls, and we'll finish up with the simple chemistry that makes old books smell so good. So, first up, the ghost in our machines. That keyboard layout we all use without a second thought, it's not the result of some brilliant modern breakthrough. Nope, it's pretty much a historical accident. Okay, so picture this. It's the 1870s, and we've got these brand new mechanical typewriters. Now, logically, the keys were laid out alphabetically. Makes sense. But here's the problem. People got too fast at typing. The little metal arms of letters that were right next to each other would swing up at the same time, crash into each other, and jam the whole machine. So this inventor, Christopher Sholes, he comes up with this kind of backwards but totally clever solution. He completely rearranges the keyboard to intentionally separate common letter pairs, forcing typists to slow down just enough to keep the machine from jamming. And that new layout, named for its first 6 keys, was QWERTY. Sholes sold the design to Remington, it went into mass production, and bam, it became the standard. And here's the crazy part. We don't have clunky mechanical arms in our laptops and our phones anymore. The original problem is completely gone. In fact, way more efficient keyboard layouts have been designed since. But we're all still typing on QWERTY purely because of muscle memory and habit. We're all living with the ghost of a 150-year-old machine. All right, let's switch gears. Next up, we're going to see how a powerful, invisible force, physical pressure, has completely dictated the shape of some of the containers we use every single day. Okay, this slide shows 2 super elegant solutions to 2 totally different problems. Your water bottle, it's got no real pressure inside, so a simple, cheap, flat bottom works just fine. It's perfectly stable. But a soda bottle, that thing is basically a tiny pressure vessel. It's packed with all this dissolved CO2 that is constantly trying to push its way out. A flat bottom would just bulge out and wobble all over the place. And that's where the petaloid base comes in. Those 5 little feet act like the arches in a cathedral, distributing all that internal pressure evenly across the base. It gives the bottle the strength it needs to contain all that fizz without going gabone. And what about toothpaste? Well, it's what scientists call a viscous fluid. Basically, it's thick, and it doesn't flow on its own. It needs a push. I mean, can you imagine trying to get it out of a rigid bottle? It'd be a complete nightmare. The squeezable tube is the absolute perfect delivery system. You apply a little pressure exactly where you need it, and you get what you need. And on top of that, it keeps the paste sealed off from air and germs, and it's super cheap to make and easy to pack. It's just a perfect marriage of the stuff inside and the container it lives in. All right. For our next section, we're shifting from pressure to protection. We're going to look at how these tiny, often unnoticed design details are actually crucial for security and, your personal safety. So, to really get this next one, we've got to jump in a time machine. For centuries, a coin's value wasn't just symbolic. The coin was the value. It was literally worth the gold or silver it was made from. And that simple fact created a huge problem. The problem was a crime called coin clipping. Thieves would literally shave off these tiny little slivers of precious metal from the edge of a coin. Now, one shaved coin was hard to notice, but if you did that to 1,000 of them, well, you had yourself a nice little profit. The solution was totally ingenious. They milled grooves, or reeds, onto the edge of the coin. Now, any filing or shaving would instantly wipe that pattern away, making the tampering totally obvious. And what's so cool is how that old-school security feature has found a completely new purpose. Our coins today aren't made of precious metal anymore, but those reeded edges are still there to help everyone, especially the visually impaired, tell coins apart just by feel. Now, let's get back to that third pin on a plug. For any appliance with a metal case, it's not just extra. It is an absolute, non-negotiable lifesaver. Okay, Here's the scenario. A wire inside your metal toaster frays and touches the metal casing. Bam! The whole toaster is now electrified. If you touch it, you become the easiest path for all that electricity to get to the ground. Yikes. But the earth pin provides a much, much easier escape route. All that dangerous electricity surges down that third wire straight into the ground. That creates a massive power surge that trips your circuit breaker and shuts off the power instantly. That little pin is your personal bodyguard against electric shock. For our final story, we're going to move away from engineering and into a little chemistry to solve a mystery every single book lover has seen. Why do the pages of old books turn yellow? The culprit has a name: lignin. Paper comes from wood, and lignin is this natural polymer that makes wood strong and rigid. You can think of it as the structural glue holding it all together. But lignin has a fatal flaw. When it gets exposed to oxygen and sunlight, it starts to oxidize. That chemical reaction breaks it down, and as it breaks down, its color changes to yellow and eventually brown. And this explains exactly why the pages turn yellow, but the cover often stays bright and vibrant. The paper used for the pages inside the book is usually pretty cheap and just full of lignin. The cover, though, is made of a higher quality paper that has a protective coating. That coating basically acts like sunscreen for the book. It blocks the UV light and the oxygen that are trying to attack the fragile lignin and ink underneath. So really, when you see a yellowing page, don't think of it as decay. It's more like a chemical signature of a life lived. It's the history of its exposure to the air we all breathe and the light we read by. From the keys you're typing on right now to the coins in your pocket, our world is just filled with these brilliant solutions to problems we never even knew existed. So the next time you pick up some everyday object, take an extra second. Take a closer look. What hidden logic can you find?